Hello, Ralph Bean here. I'm excited to show you this demo, which you can find on GitHub on Ralph Bean / LLM Compressor Hermetic demo. What I want to show is just that, a demo of using LLM Compressor in a Hermetic build on Konflux. What we're going to get out of this is an AI bomb that is enabled by Hermeto, patches to Hermeto that I demoed in a previous video, and SLSA build provenance attestations for the artifact that's produced by LLM Compressor. So what you see in this repo is primarily this compress.py script, which is like it's the equivalent of like a container file or a Docker file that a user would normally submit to Konflux if they were going to be building a container. But here we're not asking Konflux to build a container. We're asking Konflux to use LLM Compressor to take an existing model from Hugging Face and turn it into an optimized or quantized version of that model. Here, we're just using Tiny Llama as our input model and Open Platypus as an assisting data set, and using the simple one-shot API from LLM Compressor in order to do that. What makes this possible are a couple things. First of all, LLM Compressor needed a few patches in order to support using environment variables to instruct it to load its model and data set from the right locations. A new LLM compressor task was added for Konflux that's like our build a task, but instead supports the user passing in an arbitrary script, like our compress.py script, and running that in a certain context with support for multi-platform controller. Importantly, that task supports a Hermetic option so that the user can specify in a param whether or not they want that to run with network disabled in an isolated or disconnected build. And that is important for the next step, in that we added support in Hermeto for Hugging Face. So we can use Konflux's prefetch task to pull down dependencies, both the model and the data set from Hugging Face, and then make them available to the script, which then can run without network. This lets us be sure that the dependencies that we pulled and cataloged for our software bill of materials are the only things that made it into the build. There's no way, because it's running without network, that the build can pull in some other strange or unrecorded dependency, which is the primary benefit that we want to see here. So this repo is all wired up to Konflux. You can see I pushed a commit 3 minutes ago. So let's click on this and get our way into Konflux. We can see this takes me to GitHub checks endpoint, and I can navigate to a Konflux cluster and see the build that just kicked off a few minutes ago. If I go back, navigate back to the pipeline runs, we can see I've been preparing for the demo here, and so you can see a number of commits that landed in the last few minutes, as well as previously successful builds here. So let's look at one of those rather than waiting for those to finish. I find that for this particular run, it takes about 20 minutes for the LLM compressor task to finish, and a 5-minute overhead for prefetch dependencies and clone repository. We see here the 4 steps. We're initializing our pipeline, running git clone of the repository we were just looking at, running our prefetch dependency step, which is using Hermeto to get those dependencies from Hugging Face, and then finally the invocation of LLM Compressor, which is using a multi-platform controller provided node that has a GPU associated with it. And we can see that the build produced can be found in this URL. So let's switch to a terminal and see what that looks like. All right, so let's try this. With that URL, we can use cosine tree to inspect the supply chain security artifacts associated with the quantized model that we produced. And we see, as expected, signatures, an SBOM for the image, and attestations. Let's look, instead of looking, I want to show 3 things. We want to look at the SBOM. We want to look at the attestations. Before doing either of those, I want to look at the artifact itself, which may not be familiar to some viewing this video. So we use Scopio, inspect, and the URL, we're going to use the raw argument so that Scopio doesn't try to interpret this as a normal container image manifest. We're going to pipe that to JQ and that to less with some formatting. And when we look at it, what we see coming back is an OCI image manifest. It is of type VND AI model LLM compressed. We might change this depending. We might want to namespace this for the VLLM project, because this is specifically something coming out of LLM compressor. But we can see as the layers, the different blobs are the files associated with the model that was produced that came out of our task, including the recipe.yaml file and model.safetensors with a large blob size. We can use the oros command or podman artifact to pull that image. So let's demonstrate doing that here. I won't, oh, sorry. Let's pull on that image. And if we wait, it's going to start pulling down all the different pieces. I won't wait for the whole thing because it takes a while to download model.safe tensors. There are the files that I pulled in that first pass. But let's clear that. Back with that original URL, here's our artifact in Quay. We can use, I saw it set for cosine tree to look to see what artifacts are associated with it. We saw the SBOM and the attestations there, but let's look at the attestation, let's look at the SBOM first. So I'm going to use cosine, download SBOM on the image, and pipe that through JQ. Let's see if I succeeded. I did, look at that. And we see an SPDX document, know that Konflux tooling can produce either Cyclone DX or SPDX. Just happen to have it configured to use SPDX here. And we see there are 3 packages in the SPDX SBOM. One is an entry that represents the compressed demo artifact itself. It is like the self-referential bit in the SPDX SBOM. Then there are 2 more, and one represents, here you can see, of type package Hugging Face, the Tiny Llama 1.1b chat input model, as well as the Open Platypus dataset, garage-defined Open Platypus showing up there, which is good. That's what we want to see. Like I mentioned in the other demo, the Perl type being Hugging Face here, I think is really important because downstream consumers of this SBOM at some point are going to want to do risk assessment or vulnerability matching against components that have been added to models and consumed by downstream artifacts. And knowing the type of the artifact is important so that future vulnerability or risk information can be matched to the names of things along with the type of artifact and where they're coming from. The other artifact I want to show here is not the SBOM, it is the attestation. So we're going to show cosine download attestation on that same URL. We get this giant base64 encoded payload blobs. Give me just a moment while we decode that. We use payload pipe and base64d pipe from JSON, and then pipe that to less-l JSON. And here we see we get an in toto statement, which is an SLSA provenance v0.2 predicate type. We really need to upgrade to a modern version of that protocol, but here, excuse me, not protocol, of the standard, but here we are still on v0.2. But looking within, we see the build config with all of the definition of the tasks that were run as a part of that pipeline. Right? We get a record of all the steps that the model underwent on the way to it becoming a model, being much superior to any other method you would use, like say running local tools to produce your model and uploading them manually to Hugging Face. Here we get a full record of all the steps and transformations that happen to the model. With Konflux, of course, we can use Conforma, the policy engine, to gate based on various of these details of these attributes. This file goes on for quite some time, 919 lines of information about the provenance of the artifact, including all of the images and their digests that were used as part of the pipeline, the bundles and the steps, Tekton bundles and steps that describe how it was built. And so with that, that's the end of my demo. I thank you very much for watching.